part 2 is the Polygon Angle sum theorems. So this is something that I typically taught later on, like in chapter 11, but it's in this chapter in your book, so I'm going to go with it. And it's not anything that's super hard, so don't think just because I said chapter 11 it's going to be hard. So if we draw a 3-sided shape, it's a triangle. A 4-sided shape is a quadrilateral. A 5-sided, a pentagon, and a 6-sided. Are you guys noticing that as you have more sides, you probably need more like obtuse angles? Did you guys notice that? Okay, so here's my shapes. Okay, they definitely don't have to be perfect. You could measure your angles if they were perfect, but we're not going to do that. Okay, so our goal is to try to figure out how many degrees each angle, so like in this triangle, if I add up these 3 angles, do we all remember what those add up to be? Close.
180.
180, right, so 180 degrees. Okay, what do we think for a quadrilateral? 360, because remember that example I gave you yesterday, if we think about a square has 4 90-degree angles, 4 times 90 is 360. Okay, so all quadrilaterals will add up to be 360. Here's what we're going to do to prove this. Okay, you're going to choose one of the vertices, so I'm going to pick that vertex right there, and I'm going to draw in all diagonals that go from that one vertex. How many diagonals do I have that go from just that single vertex? Oh, there's only one, right? I can't draw these ones because those aren't diagonals, those are sides, right? So we can only draw in one diagonal, okay? So let's think about this. If I was to add up these 3 angles, right? Do you see those 3 angles? How many do those 3 angles add up to be? They add up to be?
180.
180. What if I have these 3 angles?
180.
They make 180, right? So if I have 180 and 180, do you guys see how that makes the total 4 angles? All of those added together makes the 4. Does that make sense? Do you guys get it? So I have 2 of the 180s, which makes 360. Because together, this makes this big angle here, the big angle here, the big angle here, the big angle here. Make sense? So let's do the same process for the next one. I'm going to pick any vertex. So let's say I pick this vertex right here. And I'm going to connect the diagonals. How many diagonals can I draw on this one from that one single vertex?
2.
2. Yep. Do you need me? You just jump in.
No, I'm just noting that my freshman son had did this problem this morning.
I had to think about it. Mm-hmm. Yep. Okay, so what are we going to have?
Sorry to do it.
Yeah.
For those of you who did not have lunch, who order it and it's running late, a bunch of them have showed up. Today,
Okay.
For instance, so I use.
Okay.
And so when you have discretionary time, like during the next passing period, you can order.
Okay. I'll give him some time. All right, so this one has how many triangles?
3.
3 triangles. And each of those 3 triangles, you guys see these 3 angles would make 180. These 3 angles would make 180. These 3 angles would make 180. They're not all congruent. I kind of drew them like they were congruent. But we have 3 sets of 180. So how many does, if I have a pentagon, what's the sum of the interior angles then?
360.
3 times 180, not 360, it's bigger, which is 540. Does it make sense? So pick any point, go to the opposite vertices. How many triangles do I have now? 4. 4 of those 180s. Do you know what 4 times 180 is? 720. Did you guys double and double again? Remember, that's my trick for multiplying by 4. So double 180, you get 360. Double again, you get 720. So we have 720. That's going to be the sum of the interior angles. That's what we call those. So interior angles are, you know, if I had a 7-sided or an 8-sided, something like this, it would be all of these angles here. All of these angles add up to be some number. So in this case, there were 6 of them. So it would add up to be 4 times 180, 720. Okay, so what's the pattern? Yeah.
You're adding 180 every single time to this.
We're adding 180 to every single time. How many 180s do we have, though? Caitlin, Colin, you paying attention? Okay, so if I have a triangle, how many sides did we have? We had 3 sides. How many triangles did we have when we connected the vertices?
1.
Well, we just had 1, right? So we had 1 times 180, which was 180. For a quadrilateral, we had 4 sides. How many triangles did we have? So look at our quadrilateral. We had 2 triangles, right? So if we have two triangles, we have 2 times 180, which is 360, right? So what's the pattern? Pentagon, how many 180s will I have? I'll have 3 times 180, which is 540. How about a hexagon? I'm going to have 4 times 180. What's the pattern? How do I go from these numbers? 3 to 1, 4 to 2, 5 to 3, 6 to 4.
You subtract 2 each.
I subtract 2, right? The reason we're subtracting 2 is because we don't connect the sides, right? So I don't have these two as diagonals, basically. So it's always 2 less. Okay, so what's our pattern if we have an n-gon? Remember, an n-gon has n sides. What do you think, Colin?
N and then n minus 2.
So, like, n is the number of sides, and n minus 2 is the number of triangles.
Yeah.
So then what do we have for the formula?
N minus 2 times 180.
You got it. Easy enough. Can we do that? So that's the sum of the interior angles. So it's n minus 2 multiplied by 180. Now, some people like to multiply the 180, and you could say 180n minus 360. Or you could write 180 first, and then times n minus 2. It doesn't matter. I usually write it like this because of the way that we derived it. We're like, okay, there's n minus 2 triangles times 180. Does that make sense? Do you guys get it? Okay, so number 1, so it says the sum of the interior angles of a hexagon. So we need to remember what these words mean. This means that we have 6 sides, right? So my sum of my interior angles is going to be 6 minus 2 multiplied by 180. In other words, it's 4 times 180, which is 720. So we could ask, what is the sum of the interior angles? Or I could rephrase it, how many degrees are there in the sum of the interior angles? What's a nonagon again? It's my favorite.
9.
9 sides, right? So the sum would be 9 minus 2 times 180, which is 7 multiplied by 180, which is what? 900? Was it 900 even? I think it's bigger. 1260? Maybe you did. You must have done 6 times 180. Oh no, 5 times 180? I don't know. Alright, so number 3. So if, 5 times 180 would be 900. Okay, so number 3. So if the sum of the interior angles of a polygon equals 900, how many sides does it have? Okay, so I'm not always just asking for the sum of the interior angles. Sometimes I'm asking, well, how many sides does it have, right? So what do you think you do, Cam?
Can't you divide 900 by 180?
Yeah, because we're going to say, let me write the formula. So our formula was our sum of our interior angles was n minus 2 multiplied by 180. So Cam's saying, well, can I put 900 in and then just divide that 180 to the other side? Yeah. So if I divide by 180 and divide by 180, 900 divided by 180 is 5. So I get 5 equals n minus 2. So how many sides does it have then?
3.
Nope. Careful. 7. You got to add that 2 over, right? Everybody always does that. You just see those numbers next to each other. You just want to combine them. All right, so it had 7 sides. What if I asked for the name of it? It's heptagon, right? Because it has 7 sides. All right, so number 4. I know, it's so tempting to call it heptagon. All right, so what is a polygon called if the sum of its interior angles equals 1440? So we set it up again. We're like, oh, well, the sum's 1440. That's going to be n minus 2 multiplied by 180. So we take that 1440 and we divide by 180. So when we do, we get 8. So if I add the 2 over, I get 10. So what do I call something that has 10 sides? A decagon. That's our answer. Easy enough? All right, so how about this one? Sometimes we just have these pictures and we're like, wait, what do these add up to be? Yeah, what do you think, Colin?
I was going to have questions.
Uh-huh.
Do we need to know the vocabulary for all the names?
Yeah, you need to know the names.
Like on the test?
Yeah. Decagon, dodecagon, nonagon. All right, so what's this one? Is it a decagon, dodecagon, nonagon, heptagon? How many sides does it have?
5.
1, 2, 3, 4, 5. Yep. It's a pentagon. I guess I said sides and I circled the angles, but same idea, right? These are still 5 sides. So we have a pentagon. So first we need to find the sum of the interior angles in a pentagon. That's how we start this. We don't know what they add up to be. So we could go and look at our chart if we want to, if you have that in front of you. But what do you think?
They add up to be 540.
Yeah, because it's going to be the 5 minus 2 times 180. So Cam's saying, oh, it's 3 times 180, which is 540. I agree. So the sum of the angles has to be 540. But this is a two-part question because we now found the sum of the angles, but we have to go and we have to figure out what x is. So we write an equation. We're like, well, all of them add to be 540. If I add x to 114 to 105 to 102 to 135, all of those make 540. So let's add those numbers, 114, 105, 102, 135. So when I add these 4 numbers, I got 456. So x plus 456. So what do I do to get x?
Subtract the 546 from 540.
Yeah, subtract that 456 from 540, and we get x equals 84. Easy enough? Can you guys handle that? That was pretty easy. I do some hard ones on your homework, though, because, you know, I gotta mix things up. Gotta make sure you're good with your algebra skills, too. You're like, great. All right. So let's talk about, so we just talked about interior angles. So interior angles are the ones that are on the inside. Exterior angles are the ones that are on the outside. Okay, this is a weird process, so everybody look up here. If I'm doing an exterior angle, I extend a side. If I extend in this direction, as I do the next one, I don't want it to overlap. Okay? So I'm not going to draw my exterior angle here, because that makes an X shape. I'm going to draw my next exterior angle here. Does that make sense? So then you guys see where the next one is? There. Okay, so these right here are called exterior angles. Does that make sense? It doesn't matter how you start the first one. Just make sure all the other ones don't cross it, okay? So like on this next one, let's say I start the exterior angle here, then this one would be here, and then here, and then, oh, it's running into the other one. That's sad. There. So we have that angle, this angle, this angle, and this angle. Okay. So do the next one, and maybe make sure you're using use a ruler to extend these lines, make it nice and straight on this last one. And then what I want you guys to do is I want you to find all of the exterior angles. So maybe, how about this table, you guys find the triangles. Okay, this back table, you guys find the quadrilateral exterior angles. And then these two tables, I want you guys to find the pentagon. Okay, so you're going to find all 5 angles. All right, so I'm going to pause. All right, so we just did the little thing with the elephant walking around, and we saw that each of these times, as we turn through the angle, we turn through the next angle, we turn through the third angle, we end up going 360 degrees around. So the sum of exterior angles is always 360 degrees. No matter the shape. So it doesn't matter how many sides we have, it's always going to be 360 degrees for exterior angles. Make sense? All right, so what do we think for number 1? Do we have exterior angles or interior angles? We have exterior, so that 2y plus y plus 2y plus y has to equal 360. So if I add all those y's together, I get 6y equals 360. So what's y? 60. That's it. How about the next one? Find the measure of the exterior angle of the regular hexagon shown below. So it's a regular hexagon, meaning all of these interior angles are the same, and all of those exterior angles would be the same as well. So how many would I have of these x's?
12.
Nope. 6 of them, because it's hexagon, right? So I'm going to have 6 of those x's. They add to be 360, so x is 60. I didn't mean for those to be the same, but you know. It's like when you take a true-false test. If you guys ever taken a true-false test and all the answers are false, you're like, why? All right. How about this one? So number 3, there's a little line here. So number 3, it says the measure of each exterior angle is 40. So how many sides does the polygon have to have? What do you guys think? It has to be 9 sides, right? Because we need for all of those 40 times the number of sides to equal 360. So n has to be 90. Not 90, what am I doing? 9. 90 sides, ooh, that'd be a lot. Okay, same idea on this one. We have 1, 2, 3, 4, 5 different angles. And they have to add up to be what? 360. These are the easiest questions. If you guys get these wrong on the test, I'll cry. So as I add these together, I have 2 plus 3 is 5, plus 6 is 11, plus, looks like 9, so 20. Did you guys get 20? A? What's A then? You can't do it in your head. Let's look at it. Fractions are our friends, right? Divide by 10 on top and bottom. The zeros go away. What's 36 divided by 2? 18. That's it. So A is 18. All right, this one says a pentagon, so 5 sides, has 2 exterior angles that are 3x. So don't forget to do 3x plus another 3x. 2 exterior angles that are 2x plus 22. So do that twice. If I didn't want to write it out twice, what could I do? Distributive property, right? Like the 2 times parentheses. And then 1 angle that is x plus 41. It has to add up to be, since these are exterior angles, 360 degrees. And then we just solve the question, solve it out. So I have 6x plus 2x is 8x plus another 2x. So I'm combining all these terms. Oops, not 22. That's not a like term. So I get 10x plus, oh, I don't get 10x. What do I get? I missed one. 11x, right? And then I have 22 plus 22 plus 41, so 85. So I take my 360 minus my 85, and I get 275 equals 11x. So I get x equals 25. So be careful though. What does the question ask for? It didn't just say what is x. What are the measures of the exterior angles? So we have 75 degrees, right? The first 2 were 3x. The next one's 25 times 2, which is 50, plus 22. So 72 and 72. And the last one is 25 plus 41. What's that? 66? Yep. And they should all add up to be 360 if you did it correctly. Easy enough? Do you guys like this section?
Yeah.
So I scared you by saying it's usually in chapter 11, but it's really not that bad. I think you guys can do it. Okay, so maybe let's pause here and we'll finish this up tomorrow. But let's go ahead and I'll give you your homework and you can start working on the homework.